how to make the building efficient. As per your experience, what would you suggest to the building operator and the building owner to make the building running very efficiently?
What are other elements that are affecting the energy consumption on the air conditioning system? Let's say the way we should think about how to reduce and make our cooling systems more efficient. So
once we have the well design of the building to be ready to hand over to the building operator, then what would you suggest to the building owner and the building operator?
In order for the AI to perform properly, we need to make sure that the data input is also proper. So they're reading the right story and not the wrong story and coming up with wrong conclusions.
Project development in Thailand starting from individual single building to be a larger scale as the mixed-use building, and now is multiple building as a city scale. The urban landscape design contributes more on the microclimate design and how to reduce the heat island effect, while air conditioning system actually release heat to the landscaping and make it worse. So as your expert on the sustainable cooling, can you suggest us more on how to do the sustainable cooling in Thailand?
Especially now we're looking towards, getting to net zero. So we want to use the most efficient solutions. And for cities, especially for dense cities and wherever you have, let's say, large towers, district cooling becomes very viable.
Thailand has just started the district cooling system provider in Thailand, and there are a lot of questions. And the most important question is the feasibility study. Can you advise us or tell us more on the global perspective of district cooling system feasibility?
District cooling and what kind of district cooling data should we be using? So all these questions are not so easy to answer, but once you have, let's say, proper data and you know the density of buildings and let's say the program on when these buildings will be built, you can start formulating an answer.
Would you recommend the typical of common efficiency of district cooling plant kilowatt per ton?
Using the thermal storage in terms of storing in at night and then delivering during the day. But now in some areas where we have more renewables, it's gonna changing now. We are using the thermal storage to store during the day and maybe deliver during the night. So it really depends on the situation, the location, and these different parameters.
What is the difference between chiller plant, conventional chiller plant, and district cooling system?
The only difference is the size and the diversity you can use. So if you have, let's say, 20 towers, each one of them is using their own central chill water plant. You're not, using that diversity. If you put one central plant for all these 20, you reduce your installed capacity. Second, the efficiency will be better because now you have all these towers loads together. You put a thermal storage tank as well, and you will run your chillers much more efficiently. So there's the scale of it, the design will be more or better, and the operation and maintenance, since you have a capable district cooling provider with specialized teams, they would run that plant way more efficient than these 20. So out of those 20, maybe 2 of them, like they have really good facility management companies and running the plants really good, but probably not the other 18.
สวัสดีค่ะทุกท่านกลับมาพบกันอีกครั้งนะคะ The Nova Talk EP นี้ EP ที่ 10 แล้วค่ะ ในวันนี้เราจะมาคุยกันในหัวข้อเรื่อง Building Energy Efficiency and Sustainable Cooling ค่ะ หัวข้อนี้เป็นหัวข้อที่สำคัญมากนะคะใน The Nova Symposium ที่เรากำลังจะจัดขึ้นระหว่างวันที่ 10 ถึง 12 กรกฎาคมค่ะ ในวันนี้เราได้รับเกียรติจากคุณ Hassan Younes นะคะท่านเป็น Co-CEO แล้วก็เป็น Founder ของบริษัท Griffin ท่านเป็น Past President ของ ASHRAE Falcon Chapter บินมาจากดูไบเลยค่ะดังนั้นในวันนี้ขออนุญาตสัมภาษณ์เป็นภาษาอังกฤษนะคะ Good morning, Mr. Hassan. Thank you for joining us today and thank you for joining us on the Nova Symposium. Hope you are well because today is very interesting and intense topic. We would like to know much more about energy efficiency. On the previous topic, we have been discussing about the building performance, passive design, building envelope. Today, we would like to discuss more on how to make the building efficient. As per your experience, what would you suggest to the building operator and the building owner to make the building running very efficiently?
Yeah, like you, started with the passive design is the most important element. I think maybe you've covered that previously. So making sure the U values, the shading coefficient of the windows, the orientation, the window to ratio. All these are designed in a way to reduce the heat input from outside to the inside. So we're in Thailand, it's a hot and humid climate. So we want to keep the outside out and make sure we have a very strong barrier that reduces the heat transfer between the inside and the outside. So I think you've covered that topic before, and this is the most important part. And normally when we look at energy efficiency, we have a pyramid which starts with the base of like passive design. Then we move into efficient equipment. So delivering that cooling required through equipment that is efficient. And at the end, we would look at renewable to offset the energy consumption, try to get to kind of a net zero building, which I think most countries now are looking towards a net zero let's say energy by 2050. For example, here in the UAE, it's 2050, and other places in the world could be 2060 or later. So it depends on the location. So like I said, important thing, passive house. And then we need to look at what are other elements that are affecting the energy consumption on the air conditioning system. So one, passive house is done, or let's say the passive design is done. We've selected materials, window to ratio is not so high. Then second, we look at the other elements of heat that are adding to the cooling load. So you have the lighting, for example, which is normally a good contributor in terms of energy or load to the air conditioning system. So nowadays we go with the technology of choice. LEDs is the technology of choice, I would say, and doing a proper design, following ASHRAE 90.1 minimum requirements in terms of lighting, power density. So currently for offices, we're able to maybe use 5 watt per square meter or per meter square and still have really good lighting. Second are the equipment that are used within the building. And again, here is the typology of the building plays a crucial role. So if it's residential, you don't expect to have heavy equipment, but you're working in a hospital, for example, you have a lot of equipment. If you're working on a lab in an office building where you have a lot of PCs, maybe some data centers, then we need to make sure that these equipment are the most efficient. Once we look at the different elements that are adding to our cooling load and make sure they are most efficient, then we look at the delivery part. So we're going to use ducts, we're going to use pumps, we're going to use fans, we're going to use chillers to deliver that load, or VRF system or DX, you name it. So we need to make sure that all the elements from, let's say, the load delivery to the load production need to be as efficient as possible. So in terms of duct design, we should allow larger ducts so we have less friction. Then we go to the fan, make sure the fan efficiency is high, and then we look at the motor efficiency. So we're kind of working backwards from the load up to the production of that cooling. Then we move into the pumps, make sure the pumps and the piping is sized properly. So ASHRAE 90.1, for example, gives really good indication on how to select the pipes based on the velocity in the pipes. Then we go into the pumps, and there's minimum efficiency requirements as well in 90.1. So we need to strive to give better efficiencies. Then we look at the motors of the pumps. Then we look at the cooling delivery. So here we're talking about hydronic system, chillers, let's say, for example, that are most common for larger buildings, let's say. So these chillers need to be as efficient as possible. And then we have the choice of going with air-cooled chillers or water-cooled chillers. Water-cooled tend to be more efficient because we're kind of using the wet bulb rather than the dry bulb and determining the heat rejection temperature. And then we go into, let's say, if we're using water-cooled chillers, then we need to have condenser pumps and we need to have cooling towers. And again, we need to size the cooling towers appropriately to reduce the lift on the compressors, which is basically the difference between the pressure of evaporation and the pressure of the condenser. So we want to reduce kind of that delta. And that's, in a nutshell, the let's say the way we should think about how to reduce and make our cooling systems more efficient. So wrapping it up, we start from the base, making sure we have proper passive design, reducing our envelope, let's say, and infiltration loads, looking at the other elements of loads, internal loads like lighting, PCs, plug loads, so on and so forth. And then we go into how we are getting that cooling from the production to these spaces and making sure it's delivered as efficient as possible in terms of design, in terms of selection of equipment to be the most efficient.
Thank you very much. I think we all know that we have to start with good passive design, but not just only the building envelope itself, but we have to select the equipment that used in that building that not produce too much heat. We have to prevent heat from outside to inside to reduce our cooling load demand. Secondly, we have to use efficient equipment. Third, not just only the efficient equipment that been using in our building, but we have to select the system itself. And lastly, cooling delivery. The cooling delivery from our center plant to the end user has to be efficiency as well.
Energy efficiency is obviously one of the most important things and the topic we're discussing, but there are other elements that need to be taken into account so that it's a workable solution, constructible solution, and maintainable solution.
Let's come to the next topic. Once we have the well design of the building to be ready to hand over to the building operator, then what would you suggest to the building owner and the building operator?
Well, you can think about that just like when you buy a really good car, and if you don't do proper maintenance of that car, it's going to be it's not going to perform properly. So the fuel efficiency might drop and you might have all kind of problems in there. So it's very similar when it comes to buildings. So you might have the best design, best equipment. You don't do the required maintenance, things will fail. So now we are, since a few years now, we look at data to do maintenance. So we used to have the reactive maintenance where we wait for stuff to break down and then we fix them. That's not what we want to do. We want to go with a preventive maintenance or predictive maintenance, or a marriage of two between preventive and predictive. So preventive is basically using the OEM recommendations of what needs to be done. When do we need to change the oil? When do we need to change a filter? And predictive is looking at data. So we can look at a filter, look at the pressure drop across the filter and change it when that pressure drop goes beyond a certain limit. We can do oil analysis on a chiller and see what is happening within that chiller and see if any intervention is required or not. So it's looking at the OEM requirements, looking at data, vibration, oil analysis, all kinds of different, points that we can extract from systems, and from that come up with decisions on maintenance. Unfortunately, maintenance in most parts of the world is still taken as a not seriously enough, because first of all, when you look at building owners, that's not their job, that's not their main task to do maintenance. So they get these subcontractors. They might not have the right technical skills in terms of the either the provider or the owner, and they don't have this proper request for proposal written properly. So recently we're working with one of the clients here to make sure we write a very detailed request for proposal for maintenance and put KPIs, what are the things they need to do and what are the things we will measure to make sure that they have succeeded or not. So this is very important to be done. The other issue that I find in buildings is maybe you would have the best building automation system or building management system, but the sensors are never calibrated. So you wait for 1-2 years, you go into a BMS and find the sensors are just giving wrong numbers and giving wrong readings. And if you have wrong readings, you have some algorithm that will take those readings and make it an actionable item, or it will not work. So that's also another important part, is to make sure the sensors that we're using, even if we want to use the predictive maintenance and the sensors are not working, it's not going to work properly. So we need to make sure that all elements are working in tandem.
So normally when the construction complete, that we will do the commissioning. But when we operate and maintenance, we have to carry on the building performance and building efficiency of all equipment, including the calibration, right? Also, the sensors has to be annually calibration according to the specification as well, to make sure that the sensor sending back to the building automation system is correct, right? And it's very important that during the operation and maintenance, we need both preventive and predictive. Predictive is very interesting because I believe nowadays we have AI data analytics that help us do the predictive maintenance, suggesting the operator to maybe replace or repair before it's actually break down, and it's also increase the reliability of the building as well, right?
The AI, because I had a discussion with our technical director a few days ago on AI, and we're discussing AI and how to use AI to promote energy efficiency or increase energy efficiency of a building. But there's a very important part, which is the building needs to be ready. So again, if we have the wrong sensors, and now the AI is reading something and coming up with algorithms that are based on false data, it's not going to be able to save energy. So in order for the AI to perform properly, we need to make sure that the data input is also proper. So they're reading the right story and not the wrong story and coming up with wrong conclusions.
Before we use AI data analytics, we have to make sure that the sensor or the starting point has the correct information sending the signal. Project development in Thailand starting from individual single building to be a larger scale as the mixed-use building, and now it's multiple building as a city scale. The urban landscape design contributes more on the microclimate design and how to reduce the heat island effect, while air conditioning system actually release heat to the landscaping and make it worse. So as your expert on the sustainable cooling, can you suggest us more on how to do the sustainable cooling in Thailand?
Yeah, so that's an interesting point in terms of the heat island effect. And when you have these distributed DX systems, so you have this kind of heat generation on different, let's say, buildings, and especially on the roofs and maybe sometimes on balconies. So it does create this heat effect compared, for example, to a large district cooling plant where all that is generated in one location, and normally it is cooled or the heat rejected through cooling towers. You don't have that much of similar, let's say, heat index compared to, let's say, DX, where it is, releasing heat at much higher temperatures. So definitely comparing both kind of district cooling versus single or standalone units, especially when it comes to the air-cooled side, the district cooling, does help in this microclimate issue. And definitely, whenever you have high density of buildings, it is the optimum solution. Especially now, we're looking towards, getting to net zero. So we want to use the most efficient solutions. And for cities, especially for dense cities, and wherever you have, let's say, large towers, district cooling becomes very viable. It's not very viable if you have like distributed houses and they're low density in terms of cooling. The cost of the piping becomes really high, and it does not become financially viable. And again, everything boils down to for it to be financially viable. If it's not financially viable, it's not going to fly.
Thank you so much. You already touched upon the district cooling system, another topic that we would like to discuss today. Thailand has just started the district cooling system provider in Thailand, and there are a lot of questions. And the most important question is the feasibility study. Can you advise us or tell us more on the global perspective of district cooling system feasibility?
Yeah, well, funny enough, I had a meeting today with a client. We're helping them to develop a large district cooling scheme, and these were the questions by the shareholders on, should we go with standalone cooling? Should we go with the district cooling? And what kind of district cooling tariff should we be using? So all these questions are not so easy to answer. But once you have, let's say, proper data and the density of buildings and let's say the program on when these buildings will be built, you can start formulating an answer. So district cooling, one, just like I said before, the density needs to be there. So you need to have a minimum density so it's viable. Second is the way the tariff is structured is also a very important factor. So normally for district cooling, you would have a connection charge, you would have a capacity charge, and you would have a consumption charge. Some people don't like the capacity charge because it's a constant charge, whether you use the system or not use the system. So I would suggest, for future, developments, to study the structure properly so the end user also is happy about the outcome. Because if you think about district cooling, there are multiple entities or stakeholders. You have the building developer, so the let's say, developer that is building that tower, for example. And then you have the district cooling provider, which could be two different entities, and in most cases they are. Then you have the end user, as in the person who bought the apartment in that tower. So developer might just develop that building, build it, and sell it off. And now they have paid only a small fraction, which is normally the connection charge, and they've left the building. And now all the tenants and the owners of those apartments are the ones paying for the district cooling capacity charge, which is normally a high, part of the tariff. And it's there for a valid reason, because the district cooling provider needs to get their money back. So the developer saves a lot of money because they have not put any standalone cooling. They've used or they paid only a small portion, which is the connection charge. And then you have the capacity charge that goes back to the owners of the individual apartments, for example. So this is a very, let's say, difficult area to navigate to make sure everyone is happy at the end. But in terms of sustainability, I don't think there's another system that could deliver the same sustainability goals when it comes to district cooling versus conventional, especially for high density areas. Reason being, the efficiency, first of all, for large plants, large centrifugal chillers is much better than a standalone. Even if you're going to use your own chillers on site, the efficiency won't be the same. One, the design is normally better for a district cooling plant. Second, the maintenance, operation maintenance is much better because that provider is selling the district cooling. So they wanted the operation and maintenance to be, in terms of cost, at least the operation or the efficiency to be at its best. So they sell and make more money. Compared to, let's say, a hotel that they have their own cooling plant, the way they will operate and maintain it is not going to be the same as the district cooling provider, where it's being treated as a utility. So you have very different, let's say, approaches to them. Also, the capability, district cooling providers have very good experience since this is their bread and butter. Every day they do this. So they know better how to manage and operate these systems. Other part is the refrigerant. So refrigerants normally in district cooling plants are managed in a better way. You don't have these leakages. In individual systems, you'll have a lot of leakages. So in terms of the global warming potential, previously ozone depletion potential was much higher and is much higher in individual systems. So district cooling, ticks all the boxes when it comes to sustainability, better energy efficiency, reduced carbon footprint in terms of operational and also in terms of embodied carbon. The only problem or the only issue would be when you have these low density buildings and you have a lot of piping to lay. But if you have a high density urban area, then definitely district cooling provides, better in all categories. It provides better options than standalone cooling.
And
yeah, maybe let me add one point on the infrastructure, especially on the electrical side of things. So whenever you have a district cooling plant, let's say feeding multiple towers, so the example I was talking about in the morning, for example, the load would be like 40,000 tons for the district cooling plant. But if it was individual standalone, it would be maybe 60,000 tons. So you have a reduced tonnage and reduced cooling capacity. That reduces the infrastructure in terms of electrical for the whole master plan. So that's another point that needs to be taken into account as well.
Oh, yes. The most important thing, the overall electrical consumption that can sometimes in Thailand, if we reach 15 megawatt, we have to build a substation on site. So if we can optimize the cooling equipment capacity, so we can optimize the substation as well. That will help absolutely. In terms of the nation electrical load demand as well.
Yeah, that's also very important. It reduces the amount of demand for the national grid, and that helps in, using that load for other developments.
Great idea. And also you have mentioned about how to reduce carbon emission from district cooling system. And also besides that, as we will visit the Forestiers project during our the NOVA Symposium on July 12th, we are taking everyone to the Forestiers project that is using the district cooling system. That's how we can create the good microclimates and people can live more outdoor. So we take everyone there to see the real case that is actually happening, and if the others can be convinced, that will be great.
And also the owners will get their roofs free, so they can put their swimming pools and they can have an outdoor area. So a lot of other benefits in terms of aesthetics as well, and usage of the building areas into better, let's say, usage than putting chillers or putting condensing units on the roof.
The next question would be, would you recommend the typical or common efficiency of district cooling plant kilowatt per ton?
Currently, we're designing a plant to be around 0.7 kilowatt per ton. However, the need for information to be able to answer that question is, so if you were looking at Thailand, you have a constant high wet bulb. So your efficiency will need to be adjusted accordingly. So for example, in Dubai, we're able to get to 0.8 kilowatt hour per ton hour on average annual. And let's say in other places, maybe a little bit lower when we have a lower wet bulb. So probably I would say in Thailand, you should still be able to get the 0.85 kilowatt hour per ton hour, or maybe lower. And that depends also on the load profile. If you have a thermal energy storage on site or not, if you have VFDs on the chillers, and how is the load profile? So the load profile is very important to dictate what would be the ultimate kilowatt hour per ton hour. But I'd say like a 0.85 should be something that is achievable with the current technology.
It was not in my question as planned, but you mentioned about thermal storage. I think this is maybe one of the key of providing or designing district cooling system. Can you suggest or advise more on that?
Yeah, so the thermal storage tank is just simply like a electric battery, but it's more of a thermal battery. And what we're trying to do here is trying to use the chillers when it's most efficient, and then extra cooling that's not required to be supplied to the buildings can be stored in the thermal storage tank. And then we would turn off the chillers, or maybe fully load the chillers in other times, and use the thermal storage as another chiller basically, and send the water or the chilled water that has been put in that thermal storage to the building. So there are multiple ways to decide on how we would go about thermal storage. It depends if in Thailand, let's say, or some regions, you might have demand for electricity or not. So if there is no demands, for example, in the UAE and GCC, we don't have demand costs. So in that case, we're trying to load level the chillers and run the chillers at like high load factor and high capacity. And in that case, we were always making sure the chillers are running at their best efficiency point. If you have demand, then you might want to check when is your demand the maximum and try to reduce it and gain some money from that, basically reduce your electricity bill. In some other areas, when we have renewables, we're now using the thermal storage during the day. So we're storing the energy during the day, and we're gonna feeding the buildings from the thermal storage during the night, because we have abundant photovoltaic, let's say, inputs that will mostly be running or producing electricity during the day when the sun is shining. And then we are changing the way we are designing thermal storage tank in terms of operation, because in most cases we would be using the thermal storage in terms of storing in at night and then delivering during the day. But now in some areas where we have more renewables, it's gonna changing now, and we are using the thermal storage to store during the day and maybe deliver during the night. So it really depends on the situation, the location, and these different parameters.
Very interesting. If you have enough RE, you can use chill water tank, the thermal stock, as one of the thermal storage instead of the battery. And I believe it's more environmental friendly as well.
Much more, and much cheaper as well.
Oh, very interesting.
Way cheaper.
And I think it comes to the last question. People here normally ask, what is the difference between chiller plant, conventional chiller plant, and district cooling system?
Well, there's not much of difference if you have like a water-cooled system versus a water-cooled system. They're practically the same. The only difference is the size and the diversity you can use. So if you have, let's say, 20 towers, each one of them is using their own central chill water plant. You're not, using that diversity. If you put one central plant for all these 20, you reduce your installed capacity. Second, the efficiency will be better because now you have all these towers, loads together. You put a thermal storage tank as well, and you will run your chillers much more efficiently. So there's the scale of it. The design will be more or better, and the operation and maintenance, since you have a capable district cooling provider with specialized teams, they would run that plant way more efficient than these 20. So out of those 20, maybe 2 of them, like they have really good facility management companies and running the plants really good, but probably not the other 18. With a central district cooling plant, you in 90% or 99% of the time, you have a capable team because they are selling that chill water. They want to produce it at the lowest cost possible. And that's why they have that incentive compared to, your chill water or your chill water being produced locally. It's not as yes, you want it to be efficient, but the objectives are different. The district cooling provider, they need to make it the lowest possible because they want to make also money out of it. And you also free some space from those buildings. So I'll give you an example. In one hotel I was working on, the original designer put the chillers at the penthouse. So they built the last floor was being used by the chillers. Now, in that particular case, we didn't have a district cooling plant that is close to it, but I moved the chillers from the top to the basement because it doesn't make sense to put chillers at the best location in a hotel. Similarly, when you have district cooling, you have all that free space to use it as you wish because you don't have to put the cooling towers on the roof, and you can use that for a swimming pool or a lounge or whatever you want it to be.
Thank you so much. I think that capture all the question people will ask, and also it's very intense and interesting topics, interesting interview indeed. Thank you so much again for joining us today.
Thank you. Pleasure.
And see you at the Nova Symposium.
Thank you
so much.
Take care. Bye-bye.
Bye-bye. และในวันนี้นะคะเราก็ได้คุยกันในหัวข้อแน่นๆในหลายๆหัวข้อเลยค่ะแต่ว่าเป็น global perspective ที่อาจจะหาฟังจากที่ไหนไม่ได้เลยนะคะเราได้เริ่มต้นจากการพูดคุยกันว่า building energy efficiency นะคะทำยังไงนอกจากที่เราจะมี building envelope ที่ดีแล้วอาจจะต้องมี equipment selection system selection แล้วก็ cooling delivery ที่ดีด้วยนะคะการ operation building นะคะเราก็ต้องมีการทำทั้ง predictive แล้วก็ preventive ด้วยหลังจากนั้นเราก็คุยกันแล้วว่า sustainable cooling นะคะเราจะต้องทำยังไง district cooling system นั้นคืออะไรการทำ district cooling system ให้ feasible สำคัญมากทำได้ยังไงบ้างนะคะวันนี้เราก็ต้องขอบคุณเป็นอย่างสูงนะคะคุณฮัสซัน ยูเนสนะคะที่ได้ให้เกียรติมาให้เราสัมภาษณ์ในวันนี้รวมถึงเป็นสปีกเกอร์ของงาน The Nova Symposium The Nova Symposium ค่ะจะจัดขึ้นระหว่างวันที่ 10-12 กรกฎาคมนะคะตอนนี้เปิดรับลงทะเบียนแล้วถ้าสามารถลงทะเบียนได้ตาม QR code ด้านล่างหรือที่เว็บไซต์ The Nova Expo ค่ะสุดท้ายนี้นะคะถ้าทุกท่านชอบคลิปนี้เป็นกำลังใจให้กับทีมงานในการกดไลค์กดแชร์กด Subscribe กดกระดิ่งดังๆด้วยค่ะ